Hello everyone. Welcome to the video lecture series on complex variable. I'm Mayur Gohil. In this video lecture, I'm taking up the following function to find the analytic function. Okay. So here the imaginary part is v equals to, vx comma y equals to y sin h to x cos to y plus x cos h to x plus into sine to y. Your hyperbolic function is given, that's why it's my major concern to guide you on that. So let us see how to do about this. So here again the standard step is there. So let f of z equals to u plus iv be analytic. Now because it is analytic, we have the derivative f dash of z is equals to ux plus ivx. Again, because of that, there are four formulas of derivative, that is vy plus ivx. Okay, so this is the first important formula that we come across. Now what we do is we go for finding the derivative of the given function. So let us write down the given function. The given is vx comma y is equal to y times sine h to x cos 2y plus x times cos h to x sine 2y. Okay, now let us take up the derivative over here. When we take up the derivative, so the first derivative is vy. Okay, so vy meaning dabba v over dabba y. So when we take the derivative, sine h to x is outside, and then we have here y cos 2y, right? So y cos 2y, when we try to take the derivative here, it will become we will use the product rule of partial derivative. So here y will remain outside, and cos 2y derivative is minus of sine 2y times 2. This is the derivative, plus we will have cos 2y remaining outside, and the derivative of y is 1. Now we go for the derivative of the second part, that is x cos h to x, that is going to remain constant. So x cos h to x is constant. Derivative of sine 2y with respect to y is going to be 2 cosine 2y. Okay, that's the answer there. Now let us find the derivative for vx. Okay, so dabba v by dabba x. When we do, what we are going to get is y cosine 2y is constant. Now when we take the derivative of sine h to x, it is going to be 2 cos h to x. Okay, after that we go for taking the derivative here. Here sine 2y is constant, and now comes the product rule with respect to x. So when we take the product rule with respect to x, so x times cos h to x derivative is 2 sine h to x. Okay, and plus we will have cos h to x, its derivative is going to be uh, here cos h to x as it is, and the derivative of x is going to be 1. So we are done over here with finding the partial derivatives. Okay, we have found them. Now what we do is the labeling part and the standard procedure which is there. So what we do here, we write down these as Vy. Now in the formula number 1, it is the first partial derivative, so that we label as psi 1 of x comma y. And in the formula number 1 again, it is the Vx is the second partial derivative, so we relabel it as psi 2 x comma y. So therefore f dash of z is equal to psi 1 x comma y plus I times psi 2 x comma y. Now it is after this step we say by Milne Thompson method, put x equal to z and y equal to 0. So we get, what do we get? Let us see. We will get f dash of z is equals to psi 1 of z comma 0 plus I times psi 2 z comma 0. Now let us see this in the next step, that what all terms remain and what all terms vanish. So here, therefore f dash of z, now what all terms remain, let us see. The moment we put x equals to z and y equals to 0, what happens here? Let us see. In the first term here, yeah, the sin h of yeah, we do get that, but in this term, let us see, this term vanishes, right? It is 0. So this is 0, and cos 2y, the moment we put it is 1. So here in the, from this entire term we will just get sin h 2z. Okay, sin h 2z is available. Then in the next term, what we get here is z cos h 2z from here, and cos 2y becoming 0, it's going to become 1. So here this 2 is remaining, so 2 into z cos h 2z, that is what we will get. So it is 2 into z cos h 2z, that is what is available. Now for the next part, I times psi 2, when we try to go about, we will get here, it is all going to vanish to 0. See how? We here we have plus I times psi 2, we have to put y equals to 0. So y is 0, so all these terms turn down to 0. Sine of 0 is again 0, so entire term is going to be 0. So it is I times 0 over here. So it finally we will have here sin h 2z plus 2 times z cos h 2z. This is what we will get. Now this is the function when we obtain f dash of z after the substitution. I have written down the question up again so that we are in a sync with what we are doing. So now we go for integration step. So we write down here, we integrate integrate both sides with respect to z. So integral f dash of z dz is going to be integration sin h 2z plus 2z cos h 2z dz. So here it is, integration sin h 2z is cos h 2z divided by 2. And now when we integrate over here, we have to be very careful because it's going to be your it's the integration is going to use UV rule. So what we do is 2z is constant. Integration of cos h 2z is sin h 2z divided by 2, right? And then we have minus sign, and 2z derivative is 2, and we integrate this again, sin h 2z, it's going to be cos h 2z over 4. That is what it is going to come. How do we get this? Because this is a single line integration that we have already seen in our basic video lecture. So I hope you remember that. It is the how it is done is we will have everything arranged as per Liate rule, LIATE. And now here if you want to add is it is cos h2z is nothing but hyperbolic, so you can add in, it is in terms of you can replace here that. Okay, so you have 2z as the algebraic function, so 2z kept out, and then you integrate cos h2z, you get sin h2z over 2. Then take the derivative of 2z, you get 2, and then you again integrate this full term back. Okay, so you will get cos h2z over 4. That is the answer. Now let us simplify this. So we have cos h2z divided by 2 plus z times sin h 2z. Okay, this 2 and 2 will be cancelled, so I'll just cancel here, and here this cancels with. Okay, so the final answer that we get is minus of cos h 2z divided by 2, and the final thing we will need to add is plus c, the constant of integration, and therefore this is my function at what I got. Therefore f of z is equals to z sin h 2z plus c. Okay, that will be our final answer because the other cos h 2z divided by 2 cancels with minus of cos h 2z divided by 2. So our final answer is f of z equals to z sin h 2z plus c. So I'll highlight it over here. Okay, this is our final answer. I hope you have followed the concept. Please go through the entire question once again so that if any difficulty is there, then please let me know in the comment section. I would be really happy to guide you on that. Please hit like button, share it with your friends, those who find it useful, and please subscribe to my channel. I'll see you soon in the next video lecture. Thank you.